When we talk about products and the impact they have on the earth, it's important to first talk about where the materials for those products come from and where they go. Matter on planet Earth is distributed within four major systems or spheres: the atmosphere, the biosphere, the hydrosphere, and the lithosphere. Modern manufacturing of products gets most of its materials from the lithosphere in the form of fossil fuels, stones, and metals, which are then mixed and recombined, sometimes becoming toxic. The materials are used briefly and then just spread out across the planet in small amounts where they can't be retrieved. According to the World Watch Institute, materials from the lithosphere are non-renewable resources, which means there is no sustainable rate of consumption for them. In the US alone, 95% of the materials flowing through the industrial economy are non-renewable. In China, just to compare, the share is 88%. The standard approach to product life cycle is sometimes referred to as cradle to grave, with materials and resources following a one-way trip from production to disposal. Cradle to cradle design identifies two separate metabolisms, biological and technical, in which nutrients recycle continually. Biological nutrients are made of materials designed to return to the biosphere, where they can biodegrade and become food within biological cycles. Technical nutrients, on the other hand, are materials that will not biodegrade or become part of any ecosystem. They remain within a closed-loop technical cycle, circulating within an industry and not allowed to contaminate any biological systems. Technical nutrients are durable substances for which the manufacturer is responsible. When this product has reached the end of its useful life, it is returned to the manufacturer for disassembly and reuse. Here in Southwest Florida, we have a diverse and delicate ecosystem that is being harmed at an alarming rate. Almost everything we use and eat is contained in plastic, styrofoam, or some other non-sustainable material. We are all well aware of the harmful effects of plastics, but what about less commonly discussed items? According to Collier County's Coastal Zone Management, some of the most commonly cleaned up items include cigarettes and rubber car parts. But to better understand why these products are so harmful in the first place, it's important to look at the harmful effect of shipping and packaging, product design, the product manufacturing process design, and product alternatives.
Designing in environmentally responsible ways is known as designing for eco-efficiency. Efficiency with the environment in mind actually generates more value, as in more product usefulness and more product financial benefit, with less energy and resource consumption and less harm done to the environment. Life cycle thinking is a central feature of industrial ecology. Product and process designers have to think about the impacts of every step of an entire life of a product, from the process of getting the materials and producing components, through processes for manufacturing, the final products, to delivery, use, and disposal of the product. Processing choices can have long-term impacts because once they are developed, they remain in place for normally decades. Depending upon the industry, the environment impacts of some processes can be locked in for very long periods of time, much longer than what you would expect. As previously mentioned, the life cycles of products like cigarettes, plastics, and styrofoam are contributing to the environmental crisis of Southwest Florida, specifically on our beaches. Currently, on our beaches in Southwest Florida, this includes Fort Myers Beach, Sanibel Beach, and the Captiva beaches, we have cleaned up a total of 90,000 pounds of ocean trash in the last 5 years as a Southwest Florida community. Reducing the impact depends on the consumer, and not only this, but on the process designers of the manufacturer. If these products are to be continued to be made, then they need to be made more sustainably to better help us in the future.
In Florida, the environment is an important part of our economic welfare. It is obviously necessary to use products that help sustain this environment in order for us to maximize the efficiency of our economy. Designing for the environment allows us to create products for the future of our economy to function in a sustainable way. The goals of design for the environment are to protect the environment from harm, to protect human health and safety, and to protect the sustainability of natural resources over the full course of the product and process's life cycle. The local American red snapper commercial fishing industry was overfished for many decades, and it led to the populations being in dangerously low levels. Through stringent regulation, cooperation with local commercial fishermen and recreational fishermen, the industry was important part of bringing the populations back.
Before designers begin working on product designs, it's important to first consider defining the product's function. It may be more eco-efficient to design the function rather than the object itself. Maybe the function can even be achieved with a different product or in a different way. Another alternative is to provide a service instead of a product. Green engineers sometimes refer to this approach using the invented words servicizing, which can be used for expensive products like cars. For example, FGCU has Zip cars on campus, which eliminate the need for each person to buy and maintain their own automobile. Users just purchase a membership and then reserve a car online, which they then can rent by the hour or by the day. It's also important to remember to use alternative products for items like plastic bags and containers by using reusable items, because this plastic breaks down into tiny pieces that are then consumed by Southwest Florida wildlife and marine life such as sea turtles and native birds. Plain and simply, if we all contribute and do our part in some way, then we can all help Southwest Florida's ecosystem slowly but surely recover.